Let's consider the three phases: solid, liquid, and gas. So the intermolecular forces and their magnitude determines which phase a substance exists in. So you know water molecule. Now you know water is a liquid at room temperature and pressure, and water has a dipole moment. The water has that dipole moment, and it's through dipole interactions and hydrogen bonding that water has fairly strong intermolecular forces, and so is a liquid at room temperature, because the forces are fairly strong between water molecules, holds them close together, and that forms the liquid phase. Okay, now let's consider the hydrogen sulfide molecule. Now this is similar to the water molecule. Sulfur is right below oxygen on the periodic table, and so it also has a bent geometry, H2S, and it has a dipole moment like water does, but the dipole moment is smaller in magnitude, and hydrogen sulfide can't participate in hydrogen bonding because hydrogen is bonded to the sulfur and not an oxygen, nitrogen, or fluorine. So there's no hydrogen bonding in hydrogen sulfide. So there are dipole-dipole interactions, but no hydrogen bonding. So the interactions between hydrogen sulfide molecules are weaker than between the water molecules, and hydrogen sulfide at room temperature and pressure is a gas. And it's a gas because the intermolecular forces are weaker, and so the average distance between hydrogen sulfide molecules is longer, so that makes it into the gas phase. So we can see phases are dependent upon the magnitude of the intermolecular forces. Now we see that sodium chloride has ion-ion forces, and so it is a solid at room temperature and pressure because of these very strong ion-ion forces. Now let's consider the phases of the following hydrocarbons. We take natural gas, methane, ethane, propane, and butane. These are all gases at room temperature. But then we go to 5 carbons, propane, hexane, and so forth, and these are liquids at room temperature. So as the molecule gets larger, the magnitude of the attractions from dispersion forces gets larger, and we finally start with methane, which has a very low boiling point, get to butane, which has a boiling point of about freezing point of water, close to 0 degrees centigrade. Then we get to pentane. So now we have a boiling point above room temperature, and it is due to the increase in the molecular weight, which increases the dispersion forces between molecules, increasing their attractions and making them into the liquid phase. Then as we got even larger, we would get to the solid phase, where we have hydrocarbons that were large enough to be in the solid phase, like candle wax is a hydrocarbon that's much higher molecular weight, so it exists in the solid phase. Now let's consider table sugar. Table sugar is a monomer of glucose and fructose bonded together, and it's a fairly large molecule, and there are oxygens, hydrogens, and so glucose fructose between itself so this is one sugar molecule and another sugar molecule, and so we can have hydrogen bonding and dispersion forces between the two sugar molecules. So the intermolecular forces between the sugar molecules are fairly large, and so this makes sugar a solid at room temperature.